Hello everyone, I'm Zahra. I work for Microsoft as a part of Linux Systems Group, LSG. This talk is going to be about an ongoing project that we have on hardening Linux kernel with architectural capabilities. To be clear, this is not a product by Microsoft, so it's more like an exploratory project that we want to see if this hardware feature can be used for security issues that we want to fix on Linux kernel, and also as a part of this process, if we can find some new vulnerabilities, attack vectors, and things like that. So I'm going to start with a very brief background, like an intro on Cherry and a state of the Morello Linux, and then some of my work on capability-based hardening and future and work and opportunities that I'm very hopeful that open source community can help us with that. So the big picture problem is that, as you all know, operating systems are really complex. We have millions of lines of code with a lot of complex abstractions, and basically any forms of proper hardening for a kernel is still an open problem. We have all kinds of software-based control flow integrity approaches, compiler-based techniques for fuzzing, and all of these approaches are helpful, but we still see lots of vulnerabilities. And some of these are memory safety, many of them are memory safety, but some are also logical problems because of this complex monolithic structure of the kernel. And at the same time, Linux kernel also has different security subsystems. We have a combination of, for example, LSMs, DAC, sandboxing techniques for example, SecComp, EVPF, and still also in this complex stack, the proper integration and hardening of these security subsystems themselves is not also a clear, we don't have a clear solution for that. And at the same time, we also have a lot of ongoing hardware security features that are adding to our hardware platforms. For example, just on ARM, we have a combination of coarse grain privilege separation techniques like trust zone Ts. We have more at the same time finer grain memory safety features like pointer authentication, memory tag extensions. And as we go, for example, on more modern hardware, we can have, for example, resource domain controllers, and all of these hardware features are not really, so they are there, but our operating system doesn't really use them, in a fundamental way, in a basically principal approach. So this is the big picture of lots of problems that we have for both hardening the kernel and also using these hardware security features properly. And Cherry is one of this fine grain, both for memory safety and for extensible compartmentalization features. That it has a really old history from University of Cambridge. I think about 14, 15 years of research is behind it. And the concept of capability-based security models, that concept is not new. We have it even on file descriptor abstraction for Linux. So basically having an unforgeable token of authority that's it's for accessing any kind of sensitive object. But the novelty of Cherry is that you have this hardware software semantic approach for bringing this concept, this memory safety concept, to both your hardware architecture in an instruction level, and also have the opportunity to redesign your systems stack based on that. So they have these extensions on MIPS, on RISC-V, and on recently on ARM. And also I think the complete example of their systems stack is based on FreeBSD. So the Linux one is a new one that's mostly ARM folks are working on. So what's Morello? Morello is basically the new development like experiments kind of like board for adding Cherry to ARM v8. And it's extending like basically the entire instructions with like new registers and new sets of like, and also extending like previous like systems registers for ARM. It's basically like introducing like the 129-bit pointers. So every Cherry pointer has like besides the value, it has the whole set of like metadata that contains its boundary of like the memory region, the object type, and the permissions, like basically for any kind of like access to that that pointer. And ARM also has this added this notion of like controlled non-monoticity. That's basically like it's trying to also because as you know, like ARM has has at least six execution levels from like EL0, EL1, EL2, and like at the same time like in the secure board. So somehow this notion of like Morello should be extended to all of these execution levels. So that's why they added this through like new exceptions sets, new executive and restrictive mode, privilege execution, and also some unsealing like operation that I'm going to describe later. So for every pointer, we have this permission set that basically by hardware you can say like this like piece of memory should have what kind of like permission access. It can have like load, execute, just store, or even more complex like access controls. Like if you want to have an immutable, for example, like region, like through sealing, or if you want to have even like systems-based like access controls, like and software-defined like base access controls, that if you want to have your own custom basically permissions to be defined for that like pointer, that capability. And the interesting thing is that like these systems, like accessing system registers that you can define to these capabilities, the behavior is still is not like really affected by your like hypervisor mode, like HPC calls, SMC calls to security monitor, and also supervisor mode. So as you can see, besides like the notion of like capabilities, you need to like change. Basically, ARM had to change like several of like system registers, including the control registers. We have new registers, for example, for bounds, for setting like converting like pointer capabilities. Like we have to like have a new like PC like program counter, like PCC, for example, instead of like PC. But at the same time, the execution levels for like EL0, EL1, EL2, and EL3, all of these should also be aware of the concept of capabilities. So most of like the control registers should also like they're also changed, and there are like you see like for example CTLR, it's now like capability based like CTLR, and the similar thing for example for thread IDs and things like that. So for example like the Morello Linux like thread struct should have instead of like thread ID, like traditionally it has like control capability-based thread IDs or restrictive-based thread IDs. That you can find most of the details in the technical manual. Similarly, as I said, like we have a new set of exceptions for basically capability-based exceptions for any faults that you get from like permissions, like accessing them, like setting boundaries like right or wrong, so things like that. So as I said, the whole details, it's like basically a lot of details, so you can find them mostly on like Cherry site and Morello project. All of them, especially the ARM one, is like everything is like open, so you can I really like if anybody in community to go and check this. So about the state of Morello Linux, it's the maintainers are most from ARM. They are really doing a very good job on basically in a very short time they have a stable environment for Linux development. If you go look at that, you see that like they're already enabled most syscalls. They're already like they have like distros like Debian, and they have both like even if you don't have like the development board, you can just use their FVP, fixed virtualization platform, something that's basically a good emulator, and the whole system is like really ready for experiment for both from the user space and the kernel development. They also from their perspective, like they modified most of like the main modifications of like memory management for adding capability-based architecture and things like that they're added. The main problems now that I'm going to discuss are from the security perspective can be from the intersections of like user and security, user space and like the kernel space security, their interactions, their shared memory, and things like that. So, for example, in my experience, when I first started with enabling some of the security features to Morello Linux. And the experiment was like really easy. I was just trying to, for example, get the T stack, like G driver running, adding like trusted keys, like BBPF, checking like if the BBPF is working like properly on Morello. And in most of the cases, when you want to add like these features to the Morello Linux, the issues that I was seeing is like minor issues. So basically mostly like pointer mismatch. Like in the current architecture that they have like a pure capability-based ABI, most of the basically most of the issues coming from like when you enable these features, like you have like traditional pointer abstractions that you need to convert them to capability-based abstraction. And for example, like when I was working on enabling the U-access, that as you know, like U-access is mostly from the Linux part. You have like all of the Linux abstraction for like function for communicating with the user space, like passing pointers, passing shared memory, and things like that. And so this required like a low-level like adding capability like instructions to Linux. And after we did that, like changing the put user, like get user, and things like that, basically like the kernel breaks like in several places. But the break was mostly on like, okay, for example here on I notify user, it says that like this pointer, like it's a like integer user space like pointer, and so it's not a capability. So basically we need to find out, like dig out like what kind of like pointer is it's like that. It's an address or it's just like an integer pointer and things like that, and try to use the abstraction, like cherry abstraction, to convert them like in a secure way to a capability. And then, for example, this one was like a kind of large patch that still needs more cleaning up. But like after fixing this, like about 50 files, but in a very like a small like lines of code, you have we have the user space like based capability backend for Morello Linux. But the tweaks are like actually the good thing about this process is that you can find out dig out if there is a basically vulnerability, like if at some of them it was just not just a cherry, like the pointer mismatch was something that could provide could be an issue like in future, like through memory vulnerability issues or things like that, or if for example they had the boundaries right and things that can go wrong, even like if we don't have cherry. So the good news is you have a lot of helper functions from the compiler for using cherry, getting setting boundaries and like converting capabilities to pointers and vice versa. So that's good. The other thing so the current state of the Morello Linux is that there's a main root capability that basically every other capability is generated from that. So what I'm working on is basically adding more like finer grain like capabilities for both sealing, like making especially like the sensitive like parts of the user space or the kernel immutable after like the operations are done. And also like, so basically we need to add more root capabilities for the user space, for like a specific capability for sealing and making the, like both the some kernel subsystems and user space some subsystems immutable. And also there, we need to use better the concept of like this software-defined permissions on Cherry. So one of the, for example, custom like permissions that are added on FreeBSD is the permission on syscalls and permission on software, for example, virtual memory. So this will kind of like let them to define like and sandboxing like environments, sandboxing and abstractions that basically is backed by Cherry. That's like this is like a really useful thing that, for example, can be like useful for eBPF or SECCOM-based syscall filtering. So the other thing that like we are working on is that like what's basically the better combinations of like this software-defined permissions for Linux sandboxing. That's basically can get a lot of like feedback. It's really useful to get feedback from eBPF guy, like folks and like sandboxing people that are working on sandboxing. So see if like we can add this kind of like abstractions and integrate them properly to Linux security subsystems. So as I said, like most of the like the goal of this project at the end is like we want to use this hardware feature, like similar hardware feature, for protecting Linux security subsystems, LSMs, eBPF, and namespace. So basically, this is a very like open like area that it can be like really benefited from community and open source community to be involved. And besides that, one of the things that it's like it's really like an early stage for it is that the whole systems stack, from the hypervisor, from secure kernels and trusted execution environments. Now, for the first time, we have this option that we can like integrate fine-grained like memory protections and scalable like compartmentalization features to, for example, or trusted execution environment. And there is like a huge area of like attack vectors between the interactions of like this secure world and like the normal world and like the kernel environment, and all of these like systems stack now have like a way to like to be protected from the secure RPC passing like pointers. That's basically is the main attack vectors for all of like T environments. Now we have the options to redesign these stacks based on these fine-grained security features. So to summarize, the state of Linux, the Morello Linux, is really ready for like especially open source community to get involved. And there are a lot of like basically open problems that we're looking forward to like get feedback from, especially like Linux community that are working on security subsystem, to both like hardening the kernel itself, hardening the kernel security subsystems, and at the same time adding more compartmentalization tools, sandboxing tools based on this kind of fine-grained features, because at the end, Linux like a privilege separation is really coarse-grained, And most of the problems are like from like these huge monolithic stacks can be solved if we have a more like better abstraction for privilege separation and compartmentalization. Also from people like if they're working on debugging and tracing, that's also like a huge like open space for capability-based systems. How we do it securely, how we basically do it properly. Now you have these options that, for example, like instead you can define, for example, secure domains for like giving some capabilities to for secure debugging, and then, for example, like don't need to be worried about like shutting down security, system security, for example, secure boot or like security features of your system just to do debugging, because as you know, like it's a by nature it's an insecure property. So I'm happy to get any questions if you have, and let me know if you're interested in working on this project.
Yeah, thank you for the talk.